Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss a topic of a differential equations, which is very important topic, a linear differential equation of nth order with constant coefficient. So, I want to discuss in detail what is the linear differential equation of nth order with constant coefficient, and how we can solve the linear differential equation of nth order with constant coefficient. So here now, first of all, we define a differential equation of nth order and first degree with constant coefficient. So linear differential equation of nth order with constant coefficient is given as below here. So here first term, I am checking here first term. This is the nth differential coefficient dny over dx, and in first term of a linear differential equation with constant coefficient. And there is multiply, here is y1 constant. There is nothing there. So here is only one number is multiply with this nth derivative. And this is the first term of the differential equation. Next plus in second term. Second term is n minus 1 order of y with respect to x. dn minus 1 y over dx n minus 1. And here is some constant is p1. p1 is some number, some constant. Similarly plus here is dn minus 2 y over dx n minus 2. This is the decreasing order 1 by 1. In first element is nth order, then n minus 1 order, then n minus 2 order, and similarly decreasing by 1 by 1 order of y with respect to x. So here p2 is also constant. Means there is no in multiply in function of x or y. Only constants are in multiply of the derivative in each term. So at last we are writing 1 by 1 decreasing the order of dependent variable with respect to independent variable. So at last of second term, second last term means the coefficient is pn minus 1. So this is the number again here, and this is first differential coefficient. So here n minus 1 order is decreased from the highest order. N minus means n minus 1. Any n is cancelled, so here is 1 order. In last second term is 1 order differential coefficient, and plus pn is also constant, and there is y is dependent variable. So y dependent variable here is decreasing order n time from highest order, and last term of the differential equation, the order is decreasing n time from highest order. Highest order is n, and n order is decreased 1 by 1. So last term is order is 0. In last term there is no order. d2 0 over dx 0 y. So this is only y here. Okay. So this is p and y equal to q. In right hand side is q any function which is function of x here. Q is the function of x here, because x is independent variable, y is dependent on x. When we will solve this differential equation, then y is the function of x. We get the value of y in some function of x. So this is known as a linear differential equation with constant coefficient. In this differential equation, there is highest order in first term, and 1 by 1 order is decreased, and at last order is 0. Then we get only y, and constants are in multiply in each term of the function of the derivative. And first term is 1 multiply in first term multiply by 1 only. In any question is given to me, in the question paper, then we write our question in the form of this equation. So this is known as a linear differential equation of nth order with constant coefficient, where P1, P2, P1, P2, P3, Pn are constants and Q is the function of x here. Say Q equal to fx. Q is the any function of f. But here we will discuss linear differential equation of second order with constant coefficients. We are taking standard equation of second order. This is very easy equation. Then we can solve third order and fourth order. We can solve any order differential equation with constant coefficient. But in first we will solve linear differential equation of second order with constant coefficients. So here we are taking a standard equation. This is d2y over dx2. Here differentiation of y with respect to x 2 times. Plus here multiply y, this second derivative is 1. Before this multiply is one number. And plus p1 dy over dx. P1 is some constant here. And this is the first differential coefficient. So here decreasing one by one order. Same here diffusion as given in first nth order differential equation. So same here formula is applied here. Here second order, here is first order, here is zero order equal to Q. So this P1 is constant and P2 also constant into y equal to Q. So this is known as a linear differential equation with constant coefficient of second order. Here Q is also the function of x. So here P1 and P2 are constants and Q is the function of x. Say Q equal to fx here. Q is some function of x here and Q is on the right hand side of the linear differential equation with constant coefficient. We are giving several examples of linear differential equation of second order with constant coefficient are as given below. There are several examples I am writing. These all examples are belongs to linear differential equation of second order with constant coefficient. Because herein multiply of every derivative in each term number only. There is no variable, neither x nor y there in multiply. So here first question, this is d2y dx2 plus 5 dy dx plus 6y equal to e to the power x. This is the q. E to the power x is the function. So this is the q, value of q here. This implied that we can write this equation in the other type. This is ordinary differential equation. Here is only single dependent variable and single independent variable. Here y depend on x. So this is known as a ordinary differential equation. This is also known as a higher order and first degree differential equation. Order is 2, degree always is 1 of this differential equation. So here d over dx, we can write this equal to capital D. If we write here, then in first term is d square, second time derivative d square, and here is one time derivative d, and here is no derivative means y. So we can write here d square plus 5d plus 10 plus 6 into y is equal to e to the power x. So here is 6 equal to e to the power x. Next example is d2y over dx2 plus 6 dy over dx plus 10y equal to cos x. So this is also differential equation of second order with constant coefficient. And right hand side is cos x. This is q. This is the function of x that is known as a q. And in left hand side, all derivatives in each term. 2 order derivative, first order derivative, no order derivative. Which each term there are number in multiply. This is basic concept of the linear differential equation of second order with constant coefficient. Next example also same is second order differential coefficient. Here plus 6 is number multiply with derivative, first order derivative plus 8 is number multiply with y. Y is dependent on x. Y is dependent variable here. and equal to x square. X square is q. Q is x square here. In right hand side there is some function of x only. Single independent variable only here. So in this here we are showing several examples which are related to linear differential equation of second order with constant coefficient. You understand clearly that in each derivative, in each term, and there is multiply the numbers with derivative in each term, and in right hand side there is some function of x. So this differential equation is known as a linear differential equation of second order with constant coefficient. Now here we will discuss in detail how we can find the solution of linear differential equation of second order with constant coefficient. How we can solve this equation? So we are discussing about the topic how we can find the solution of a given differential equation with constant coefficient of second order with constant coefficient. So here I am taking one equation of second order, that is standard equation. Standard equation means there is only two order standard. I am discussing only two order. After that we can find any higher order, more than 2, 3 order, 4 order. But we are discussing here only two order. So d2y over dx2, this is the second order derivative. And here multiply by one constant here. Plus next constant is p1 and dy dx first derivative here. And plus p2y is equal to q. Q is the function of x. This is general equation. We are taking standard equation of linear differential equation with constant coefficient. P1 and P2 are constant. Q is the function of x here. And order, highest order is 2. And one by one order is decreasing. In every term, one order is decreasing. So 2, here 1 and 0. This is the order. Highest order 2, then next order is 1 and next order is 0. 0 means there is only y, no order of y, no derivative of y. So this is linear differential equation of second order with constant coefficient. This is general linear differential equation I am taking here. Now solution of one. How we can solve this one equation? So we use here method. We use here method y is equal to cf plus pi. In every linear differential equation with constant coefficient of second order or third order or n order, we use this method. This method is known as a complementary function and particular integral. So in this equation, first we find the complementary function and after second part, we find the particular integral. So we are adding complementary function and particular integral, both solutions are adding, then we get complete solution of the differential equation. So in solution of a differential equation, we find value of y in some function of x. Always. We find the value of y in left hand side and in right hand side is some function of x. That is the solution. For complete solution, in first part, we find out the complementary function. And in second part, we find out the particular integral. So one by one, we are discussing how we can find complementary function and then how we can find the particular integral. We are also discussing that when we are finding the particular integral, when we are not finding this. Okay. So here y is equal to complementary function and plus particular integral. This is the complete solution. Y equal to is complete solution. Complete solution this. First we find complementary function of given differential equation 1. So then when we find the complementary function of given differential equation, then taking right hand side of the given differential equation is equal to 0. When q is 0, then we find complementary function. So we are taking q is given or not, that is other thing. If q is given, Then sometime for finding complementary function, putting the value of q is equal to 0. We are right hand side taking 0. Then we can find complementary function. So here q is equal to taking 0. Then we have this equation 1 convert in equation 2. d2y over dx2 plus p1 dy over dx plus p2 y is equal to 0. This is the value of q. I am putting here q equal to 0. So q is 0. This is the equation 2. We find the complementary function of equation 2 because in this differential equation right hand side is always 0. So I am putting here right hand side 0. Q is 0 here. So let us consider now. I am considering some function. That function is the solution of this differential equation 2 and that function verify to this differential equation 2. So I am considering here y is equal to c1 e ki power mx. c1 e ki power mx. This is equation 3 and this is the solution of this equation 2. This is I am considering only y is equal to c1 e to the power mx is the solution of equation 2 when we are taking right hand side 0. Equation 3 is the solution of equation 2 here. This is equation 3, y is equal to c1 e to the power mx and this function, this is the function of x. This function verify to equation 2. So this is the solution of equation 2 here. And equation 3 verify to equation 2. Here equation 3 verify to equation 2. After verifying, then we get. Means how we can verify? This value of y equal to c1 e ki power mx. So place of y putting c1 e ki power mx in differential equation, in given differential equation. So I am putting y equal to c1 e to the power mx in given differential equation. So here we write here d2 over dx2 in y, this is y, c1 e ki power mx plus p1 is number constant, d over dx c1 e ki power mx and plus p2 is also number here, multiply by this. So this is y here, y is c1 e ki power mx equal to 0. Because this function is not known function, I have considering this function. So this is not verified to this equation, but I am putting 0 equal to. If I am putting 0 means it is verified already. Then we get some relation here. If any function does not verify to any question, then we get there some relation. Okay. If not verify, then we get relation. If verify, then we get right hand side is equal to 0. So here this is not verified, but I am putting here 0. So 2 time differentiation of this. C1 is constant, e to the power mx. Differentiation of e to the power mx is no change. E to the power mx and into m. And mx, differential of power mx. Mx, x is 1 and into m. So, and 2 time differentiating. So I am writing here c1 m square e to the power mx and plus p1 c here 1 time differentiation of e ki power mx. So here p1 c1 m e ki power mx plus next p2, there is no derivative here. This is same as I am writing here c1 e to the power mx equal to 0. So after differentiating we get this equation. Now here c1 in each term, I am finding c1 in each term, that is constant, that is already I have taken in our solution. So c1 is common and e to the power mx is also common. So e to the power mx is also taking common here. Now remaining terms are, in first term is m square plus p1m plus p2 equal to 0. This is equation number 5. After verifying the differential equation y our considering solution, then we get this result here. Now in equation 5, c1 e ki power mx, one formula is this a dot b equal to 0. Then either a0 or b0. This is the formula. There are only 2 number and multiplication of 2 number is equal to 0. Then either first number 0, second is not 0, or second 0, then first is not 0. This property is always verified in multiply. So here two numbers, one is this one, other is this one. So both multiplication is equal to 0 here. So first this is not 0. I am taking C1 e to the power mx is not equal to 0. Why this is not 0? Because I am considering this function as a solution of my question. If I am taking this 0, then solution is 0. So I am considering this function as a solution. So this is never 0. This is not equal to 0. This is equation 6. Because 6 is a solution of equation 2. But m square plus p1m plus p2. M square plus p1m plus 2 equal to 0. This is equation 7. This must be 0. We find out the value of m here. So this result must be equal to 0. This is 7. This is known as a auxiliary form of equation 2. The equation 7 is known as a auxiliary form, as an auxiliary form of equation 2. But this auxiliary form is a quadratic equation, same quadratic form. Now we know that a quadratic equation is ax square plus bx plus c. In 10th class, we have already seen this. Ax square plus bx plus c equal to 0. This is quadratic equation. This is equation number 8. And this is equation number 7. 7 and 8 both are same. We know that equation number 7 and 8 are same here. So quadratic equation in m and solving 7, finding value of m. Here we want to solve equation number 7. 7 equation is a quadratic equation. So we apply the formula of quadratic equation. We find the solution of 7. And variable is in 7 is m. So we find the value of m here. This is quadratic equation. So value of m is 2. m1 and m2. So now which formula we apply here? That is Dharacharya formula. We are using here Sri Dharacharya formula. Sri Dharacharya is a very famous mathematician who gave solution of a quadratic equation, second degree equation, and after making perfect square, he find the solution of quadratic equation, and he give the solution of a quadratic equation equal to m equal to minus b plus minus under root here minus b x m equal to here minus b plus minus under root b square minus 4ac upon 2a. This formula is given by Sri Dharacharya formula. This is Indian mathematician who give this formula. Comparing equation 7 and 8. 7 is quadratic equation, general quadratic equation, and 7 is given equation here. 7 is equation 7, this is m, and 8 is quadratic equation. So comparing with 7 and 8, then we find here. Then we have a equal to 1. Okay, a is 1 here. Here a x square, before x square is a here, and here is m, here is x. No problem. But terms are same here. So here is m square and x square. Here a is 1. So a is 1. After comparison, b is p1 and c is p2. So after finding value of a, b, c, after solving equation 7 to find value of m. Here roots of m are 4 types. We get from Sri Dharacharya, roots of m are in 4 types roots. So here 4 cases arises here. Here we will discuss every case one by one in detail. So case 1, I am applying here case 1. Roots of m are different of equation 7 of 7. If roots of m are different, so let roots of m are m1 and m2, different roots. Then we apply formula of complementary function CF of 7 is. This is the formula. CF equal to C1 e to the power m1 x plus C2 e to the power m2x. How we can write this formula? We have considered the solution y equal to c1 e to the power m x. But m has two value here. So here c1 e to the power m is m1x and plus c2 next constant. This is first solution. And second value of m, then that is second solution, e to the power m2x. So this is CF of given equation here. Formula of CF of 7 is CF C1 e to the power m1x and C2 e to the power m2x. M1 and m2 are roots of m. M1 and m2 are two values of m in given difference, given auxiliary form. Where C1 and C2 are arbitrary constant. Case 2 here. Roots of m are equal. Equal means m1 equal to m2. m2 equal to m1 equal to m2. Are m1 m1 roots. Two roots are m1 and m1 of equation 7 is. Then we find the CF complementary function here. C1 plus C2x e to the power m1x. Here roots m equal to our same roots m1 comma m2. m1 comma m2, two roots are there. So complementary function equal to C1 plus C2x e to the power mx. This is derived formula. But here I am not giving proof of this formula. So I am writing direct this formula. We can also proof of this formula. So here we apply direct formula this. After proving, we get this formula. So here C1 and C2 are constant. Case 3, roots of m are imaginary. If roots are, in first case, roots are different. In second case, roots are same. In third case, roots are an imaginary, alpha plus minus I beta. Then we apply here complementary function equal to e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. How we can find this formula? We can prove this. So now, next formula of complementary function is c1 e to the power alpha x cos beta x plus c2. This is 11 equation. So here I want to discuss this, how we can find this solution. So here m equal to alpha plus minus I beta. These are the roots. So m equal to here m1 equal to alpha plus I beta and m2 equal to alpha minus I beta. So here these are the different roots. Roots are different. m1 is not equal to m2. So we apply first formula here. We apply here first formula 1. So CF is equal to C1 e to the power alpha plus I beta into x and plus C2 e to the power alpha minus I beta into x. Okay. So I want to prove how we can find this formula. How we can find this formula. Direct I am writing. Okay. So here C1, I am writing here C1 e to the power alpha x into e to the power I beta x and plus C2 e to the power alpha x into e to the power minus I beta x. Okay. So e to the power alpha x is common here. E to the power alpha x is common. So here C1 e to the power I beta x, e to the power I beta x and plus C2 e to the power minus I beta x. Okay. Now I am writing this here C1 e to the power alpha x C1. This one here formula of e की power I theta. This is cos theta plus I sin theta. This is formula I am writing here. So here cos beta x plus I sin beta x and plus C2 here I am writing cos beta x minus I sin beta x. Okay. So here taking imaginary part here, e to the power alpha x in bracket cos beta x is common in bracket c1 this into and c1 plus c2 and plus sin beta x is common. So here c1i and plus minus c2i. So this is constant here, this constant. So I am writing here e to the power alpha x and this is constant c1 dash cos beta x and plus this c2 dash sin beta x. So this is formula I am writing. Any apply first formula e to the power m1x. This formula I am applying here e to the power m1x. Here I am applying formula of CF e to the power m1x and plus c1 and c2 e to the power m2x. This formula applying, we get here this formula for imaginary case. We can this again convert in second formula. So what is second formula here? E to the power alpha x. I am considering c1 dash. C1 dash I am writing here c1 dash. Here I am writing c1 dash equal to c1 dash equal to c1 cos beta x cos c1 cos c2 c1 dash this equal to c1 cos c2 and c2 dash equal to minus c1 sin c2. So this value putting here cos beta x and c1 cos c2 and minus sin beta x and c1 sin c2. So c1 is common e to the power alpha x in bracket cos beta x cos c2 and minus sin beta x and sin c2. Okay. So cos A cos B minus sin A sin B. So we write here formula C1 cos e to the power alpha x is already common. C1 e to the power alpha x and cos beta x plus C2. So this is next formula I am giving here. Roots of m are conjugate roots. Case 4. Here I am taking case 4. Roots of m are conjugate roots. What are conjugates? Conjugates means in under root in Dharacharya formula in b square minus 4ac is not a perfect square. Minus b plus minus under root b square minus 4ac upon 2a. So b square minus 4ac is not a perfect square. Is not a perfect square, this one. Then here we find some number in roots and positive greater than 0. B square minus 4ac is greater than 0 and is not a perfect square. Greater than 0 is not a perfect square. Is not a perfect square. B square minus 4ac. Then we get conjugate roots of an auxiliary form alpha plus minus root beta. Then complementary function I am writing here e to the power alpha x c1 cos hyper. This is same formula in case 3 and case 4. Case 3 is imaginary roots. Case 4 is conjugate roots. So case 3 imaginary roots there is writing cos beta x, but here is hyperbolic. In conjugate roots we write this formula e to the power alpha x c1 cos hyperbolic beta x plus c2 sin hyperbolic beta x. This is also proved formula. We can here also prove this. Let formula last formula this also can be written as c1 e to the power alpha x cos hyperbolic beta x plus c2. So this formula, if roots are conjugate roots, then our answer of CPI is in of complementary function in hyperbolic. We write in hyperbolic. Linear differential equation of second order with constant coefficient is given as this. I have taken in equation 1, same as here. Here q is 0. If here is q is 0, then this equation convert into second equation. Okay, we are taking only q is 0, then putting here q is 0, this equation convert into, if in equation 2 right hand side is 0, rq is 0, we are check out the linear differential equation with constant coefficient of second order. In right hand side is 0 means q 0, then we find only complementary function of two equation. We find only complementary function of 2, and here pi is 0, we cannot find pi of a linear differential equation. Yes, of, here we are giving some examples on each cases one by one. Case 1, roots of an auxiliary form are different. First case. Case 1, roots of an auxiliary form of a differential equations are different. So problem 1 based on case 1. So here I have taken some problem. d2y over dx2 plus 5 dy dx plus 6y equal to 0. This is differential equation of second order with constant coefficient. But right hand side is 0. Any q is here 0. So here equation in solution. I am starting the solution. So this is equation 1. Putting d2 over dx2 is d square and d over dx is d here. Then equation 1 can be written as here d square y plus 5 dy plus 6y equal to 0. So y is common here, d square plus 5d plus 6y equal to 0. So putting here d equal to m in equation 2, then we get auxiliary form. Y is removed from here. Y is a function, so y is removed from here. Same y is not 0, this result 0. So we are taking this result 0. So m square plus 5m plus 6 equal to 0. So 3 2 just 6, 3 2 plus 5. We are factorizing this or solving by Sridharacharya formula. So now factorizing equation 3, then we get m equal to minus 3 minus 2. So this is the value of m. M is m1 equal to minus 3 and m equal to m2 is minus 2. So roots are different here. I am checking out here, roots are different. So this is the solution. I am writing here formula. Formula is this. Y is equal to Cf equal to C1 e to the power m1x plus C2 e to the power m2x. I am putting value of m1 minus 3 and minus 2. So this is the formula, and only this is the solution of differential, because here q is 0 here. In our differential equation q is 0. So we not find the pi, only complementary function is the solution complete. So y equal to Cf is this complete solution. Next one, problem 2 based on case 1. Same case 1, roots are different. Here roots are different here. Different. So I am writing here d square plus 7d and plus 10 into y is equal to 0. We can write this here. And putting d equal to m, d equal to putting m, and y remove from equation. Okay. So here m square and plus 7m and plus 10 equal to 0. So factorizing this, m square and plus 7, 5 2 just 7, 5m and plus 2m and plus 10 equal to 0. So m square equal to 5m and plus 2m and plus 10 equal to 0. So m is common, m plus 5 plus 2 common, m plus 5. So m plus 5 is common and m plus 2. So m this equal to 0. So m equal to minus 5 and minus 2. So here CF is C1 e to the power m1x and plus C2 e to the power m2x and C1 e to the power minus 5x and plus C2 e to the power minus 2x. This is CF and this is Y, and this is solution of this question. Okay, complementary function. Now problem 1 based on case 2, roots of m are equal here. We are showing here roots are equal, but in case first roots are different. So here I am taking differential equation d2y over dx2 minus 10 dy dx plus 25y equal to 0. So here d2 over dx2 is d square and d over dx is d. This is equation 1. So here putting d square y minus 10 dy and plus 25 y is equal to 0. Y is common. Y taking right hand side common, not left hand side. If you are taking y left side, then you wrong. So I am taking here d square minus 10d and plus 25 into y is equal to 0. Okay. So d equal to putting m and removing y. Removing y from question, from equation. So here m square minus 10m and plus 25 equal to 0. This is an auxiliary form. This is an auxiliary form. Auxiliary form. Okay. So solving this here, m square minus, here is 5 5 ja 25 and 5 plus 5 10. So here is 5 plus 5 and m plus 25 equal to 0. So now here m, वैसे भी m square minus 5m and minus 5m m plus 25 equal to 0. So m minus 5 and minus 5 m minus 5 equal to 0. So m minus 5 and m minus 5 here. Okay. So this is m minus 5 ka whole square. So m equal to here 5 and 5. Equal roots are there. Here is equal roots. So I am writing formula here. Formula is CF is equal to C1 plus C2x e to the power 5x. This is formula. This is equal to y. This is solution of 1. Similarly, we can solve this here. So d2 over dx2, this is d square, and d over dx is d. So I am this equation 1. Writing here d square minus 4d and plus 4, y is common, equal to 0. Putting d equal to m and removing, then we get here m square minus 4m plus 4 equal to 0. So m minus 2 ka whole square. This is perfect square. A square plus b square plus minus 2ab. This formula is applied in this here. Then we get m equal to 2 and 2 roots. Okay, equal roots. So we apply here formula y is equal to c1 plus c2x e to the power mx. This is formula. So y is equal to c1 plus c2x e to the power 2x. This is solution. Okay. Now, case 3. Problem 1 based on case 3. Case 3, roots of m are imaginary. Here, m equal to alpha plus minus I beta. I am solving this problem here. So here same, d2 over dx2 is equal to d square and d over dx is equal to capital D. So I am writing equation 1. This equation 1. Here is d square minus 4d and plus 5 into y is equal to 0. Putting d equal to m and y removing. Then we get here m square minus 4m and plus 5 equal to 0. Now solving this, m equal to, here this is quadratic form. So here apply a equal to 1 and b equal to minus 4 and c equal to 5 here. So I am writing here m is equal to minus b plus minus under root b square minus 4ac upon 2a. This formula. This is known as the Sridharacharya formula. So here m equal to minus b means minus 4 means plus 4. Plus minus under root b square means minus 4 ka whole square 16 and minus 4 ac. minus 4 is C. What is C? C is 5. A1 and C is 5 upon 2A2. So this equal to 4 plus minus under root here 20. So here I am writing minus 4 upon 2. So here is 4. 4 plus minus this is 2I and divide by 2. So I am writing here 2 plus minus I only. This is M. So this is the root. These roots are alpha plus minus I beta. This is this type root M. So I am writing formula here. Y is equal to, here I am writing formula y is equal to C1 e to the power alpha. Alpha is 2, here alpha 2 and beta is 1. So e to the power alpha x 2x and in bracket C1 cos x plus C2 sin x. Okay, this is solution. Same problem 2 based on case 3. Roots of m are in imaginary roots. Okay, are imaginary roots. So here same d2 over dx2 this equal to d square and d over dx is equal to d. This equation is 1. So I am writing here d square minus 6d and plus 25 and into y is equal to 0. So putting here d equal to m. When we are putting here d equal to m, we get an auxiliary form. This equation convert in direct auxiliary form. So here is and y removing here. Y remove. So we get here m square minus 6m plus 25 equal to 0. This equation 2. Solving this equation by Sridharacharya. So comparing here, a is 1 and b is minus 6 and c is 25. So I am writing here formula m equal to minus b plus minus under root b square minus 4ac upon 2a. This is Sridharacharya formula. To solve any quadratic differential equation, we can solve. So m equal to here minus b means 6 plus minus under root b square 36 minus 4 into a1 or into c 25 upon 2a2. So here 6 plus minus under root 36 minus 100 upon 2. So here 6 plus minus under root, here is minus 64 upon 2. So here is 6 plus minus 8I upon 2. Okay. So here I am solving this m equal to what result here? 6 plus 8, any 3 plus minus 4I. This is alpha plus minus I beta m. So m equal to here alpha is 3 and beta is 4. So I am writing here y is equal to CF. This equal to C1 e to the power alpha x. Alpha x means 3x and in bracket CF is equal to e to the power alpha x 3x and in bracket C1 cos beta x. Beta x means 4x plus C2 sin beta x. Okay, this is answer. C2 sin beta x. This is C2 sin beta x. Now, problem 1 based on case 4 here. Roots of m are conjugate. Conjugate roots. Conjugate roots means alpha plus minus root beta. So here same, I am writing here this equation d square minus 5d and plus 5 into y is equal to 0. This equation 1 and this equation 2. Both equation are same. This is the derivative. Derivative d over dx is d. d2 over dx2 is d square. So now putting here d equal to m and y removing y from 2. Okay, because y is not 0, this result is 0. So m square minus 5m plus 3 equal to 0. Now solving this, a is here 1 and b is here minus 5 and c is 3. So here m equal to minus b plus minus under root b square minus 4ac upon 2a. So this equal to minus b. Minus b means 5 plus minus under root b square. B square means 25. Minus 5 ka square plus 25 minus 4ac. 4ac. A1 C3 upon 2. So here 5 by 2 plus minus 1 upon 2 under root. Here is 25 minus 12. So here 5 by 2 plus 1 upon 2 plus minus under root 13. This is the value of m. 5 by 2 here. 5 by 2 plus minus 1 by 2 under root 13. This is alpha plus minus root beta. So we apply here formula. Formula is apply here. Y is equal to here CF is equal to here e to the power alpha x. Alpha, what is alpha? 5 by 2. E to the power alpha x, 5 by 2x. And cos C1 e to the power C1 e to the power alpha x. In bracket C1 cos hyperbolic beta. Beta, what is beta? Beta is root 13. Beta. Beta x 13x and plus C2 sine hyperbolic 13x. This is answer. This is the last problem, problem 2, based on case 4 here. So here same problem is this. Here d square and minus 10d plus 9 into y is equal to 0. So here this equation here 1 and this here 2. We write this equation in d form. Putting d equal to m and removing y. Then we get here m square minus 10m and plus 9 equal to 0. So a is here 1, v is here minus 10 and c is here 9. So m equal to formula minus b plus minus under root b square minus 4ac upon 2a. So here I am writing formula minus b. Minus b means plus 10. Plus minus under root b square means 100 minus 4 into 1 into c into 9 upon 2a 2. So 10 plus minus under root 100 minus 36 upon 2. So here m equal to here 5 plus minus under root here 6. This is roots are not equal here. Roots are equal वाला formula लगा दो. So here is 36 and 100. तो यहाँ 64 आए. Okay. 64 by 2. So here is 5 plus minus. Here is 8. So here m equal to here 5 plus 8 equal to 13 and 5 minus 8 equal to minus 3. So roots are here different. So this question goes to in case first. Case first is m equal to here roots of m equal to here 13 and m equal to m1 ye and m2 equal to is minus 3. So roots are different here. Roots are different. So this is case 1. This is case first here. So y is equal to cf. I am writing formula e to the c1 e to the power 13x and plus c2 e to the power minus 3x. So this question goes to in case 1 because roots are different. Here roots are different. Roots are here different. Okay. In this question, roots are different. Roots are different. So case is 1 here. This is the answer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.